and welcome to the session, everyone. So today, the topic that I'm going to be talking about today is the basics of how to conduct a security code review. So is the process of how to find vulnerabilities by looking at source code. And you might notice that the title says for both developers and penetration testers. This is because I believe that this will be a very useful skill for you no matter which side of security you're on, right? So if you're a developer, learning how to find vulnerabilities in your own code can enable you to write more secure code in the future. And if you're a penetration tester, then by learning how vulnerabilities manifest in source code, you can learn to conduct deeper and better analysis. And source code would be another way that you can uncover vulnerabilities in the programs that you're auditing. So let's get started. So first, hi, my name is Vickie. I am a developer and a penetration tester, and I currently work at a company called Shift Left as their developer evangelist. I'm also the author of a book called Bug Bounty Bootcamp, which aims to help beginners get into bug bounties and web application hacking. And you can find me on Twitter at VickieLee7. And so first of all, before we jump into actually reviewing some code, let's first talk about the agenda that we're going to be doing today. So we're going to be talking about manual code reviews. That is, you're diving into code yourself and trying to find vulnerabilities in the code without using any tools. And we're going to be talking about why you might want to learn how to do that, despite all the automated tools available to you today. And then we're going to jump into how do you actually prepare for a source code review. What kind of tools do you need? What kind of prerequisite knowledge that you need to study up on before you jump into your first security code review. And then we're going to actually dive into the process of reviewing code, and I'm going to show you some examples of finding a few vulnerabilities in the example application that we're going to be looking at. So first of all, let's talk a little bit about why security code review is such a valuable skill. So a lot of application security issues are actually derived from insecure coding practices, right? Like SQL injections, for example, is caused by a lack of or improper input validation. And issues like cross-site scripting and different kinds of injection can be caused by a lack of output encoding or a lack of input validation. And issues like insecure direct object references or IDORs or information leaks are often caused by missing access control. And issues like server-side request forgery, they're often caused by weak or missing regex checks, right? So all of these vulnerabilities actually have root causes that are very easily identified in source code itself. So one of the easiest ways to actually find these security issues is by diving into source code instead of using dynamic testing tools or using penetration testing teams. It's much easier to just look at source code and see if any of these vulnerabilities, their signatures are happening within the source code. And this is like one of the easiest ways to find vulnerabilities. And second of all, I'm also a huge proponent of learning to read source code and learning to identify vulnerabilities in order to become a better penetration tester or a better developer, right? Because throughout the process of reviewing the code manually to find security issues, you'll learn a lot about different vulnerabilities as well as how they manifest in source code and how they manifest in sort of different programming languages, different environments, and so on. And as a result, you'll learn very deeply about security issues, and you'll learn to write more secure code in the future, right? And if you're a penetration tester, you'll understand the root causes of the vulnerabilities that you're looking for much deeply, and that will enable you to conduct deeper and more comprehensive analysis in the future as a penetration tester as well. So let's get started preparing for a source code review. And so first of all, what are the tools that you need in order to conduct a source code review efficiently? You actually don't need that many tools. One of the absolute essential tools is a good code editor or an IDE that you can use to interact with the code. And there are three things that you should be looking for a good IDE for a source code review. And one of them is that you want an IDE or a code editor that allows for global searches across the code base. You'll see why later, because we'll be searching for vulnerable signatures in code across the entire project. And a lot of the times, that's how you find vulnerabilities, right? So you want the ability to be able to search for a particular signature or a particular function across the entire code base. And when we're searching for vulnerable patterns in code, you're not always looking for a specific string or a specific, like a very fixed thing, right? Sometimes you'll be looking for string patterns instead, and that's when regex searches come in handy. So you'll want a code editor that comes with a regex search functionality as well. And then third of all is that you want the ability to be able to cross-reference multiple files at the same time. Because a lot of the times when you're trying to confirm that a vulnerability actually exists, you'll need to cross-reference several occurrences of the same functionality, or you'll want to see where the data is going, where the code is going. So you'll need to open the same you'll need to open several different files at the same time, and that really make things easier for you. So these are the three basic criteria that you should be looking for, and it's really not that hard to find. I'll be using Sublime Text today, but you're free to use any code editor or an IDE that you like. And second, I'm also a big fan of having some sort of scripting tool or the terminal on hand, just so that I can run tests on the code base and really verify my hypotheses about how the code is actually working. And so before we go on, let's first discuss a few code analysis concepts that you need to understand. So in the code analysis world, a source refers to the code that allows a vulnerability to happen, whereas a sink refers to where the vulnerability actually happens, right? Let's illustrate this by looking at a vulnerability. Take command injection, for example. A source in this case would be a function that takes in user input, whereas a sink, on the other hand, would be a function that executes system commands. So if untrusted user input can get from this source to the sink without proper sanitization or validation, then a command injection vulnerability exists. So many common vulnerabilities can actually be identified by tracking this data flow from appropriate sources to their corresponding sinks. And so the second thing that you should prepare for is that before you actually start reviewing code for vulnerabilities, you should start by learning what the most common vulnerability types are for your application type so that you'll know what to look for, right? For instance, if you are reviewing an application with many different users, then information leaks might be an issue. And if your application lets the users interact with the database via their user input, then you might be looking at some SQL injections, for instance. So knowing what the major vulnerabilities are and getting familiar with the indicators and the signatures of those vulnerabilities will really help you look for similar patterns in your source code. So also be familiar with what are the common sources and common sinks of each type of vulnerability, right? For instance, the signature for XML external entity or an XSE vulnerabilities is passing user-supplied XML into a parser without disabling DTDs or external entities. So you should be arming yourself yourself with the knowledge of what these vulnerability looks like in your application's context. So although like vulnerabilities have these like very very vague patterns in code, these patterns can look quite different depending on the programming languages or the libraries or the frameworks that you're using. So learning what the common vulnerabilities look like in your specific context would help you a lot in, actually spotting vulnerabilities very accurately in your source code. So next up, this slide is for the penetration testers. If you did not build the application yourself, you should also try to get familiar with the functionalities and the components of the application, right? Where are the important functionalities, as well as what are the important components in the application. So first, you should probably figure out who the application's users are, what can each user do, what kind of data the application is processing, as well as what are the business impact and the business significance of each functionality and each component. So this will really help you prioritize your analysis down the line, because you understand what could realistically go wrong, as well as what kind of data that's the most important for you to be protecting. Because a lot of the times during source code review, it's not very realistic to read every single line of every single component in the code, right? So you really need to start with the parts of the application that poses the highest risk to the application's user as well as the business itself. So let's start analyzing some code. So first of all, if you are short on time, focusing on searching for the most common and the most severe issues will give you the highest ROI, right? And a quick way to start doing this is by searching for the strings, the keywords, and the code patterns that are known to be indicators of common vulnerabilities or misconfiguration. For instance, hard-coded credentials are a huge issue, right? That you can very easily identify in source code. And hard-coded credentials like hard-coded API keys, encryption keys, and database passwords, they can very easily be identified a lot of the times by searching for keywords in the code base, just by searching for keywords like key, secret, password, and so on. And another vulnerability that you can look for this way is by searching for unchecked use of dangerous functionalities. So search for the code base for the use of dangerous functions and see if they are reachable by user control data, right? So for instance, you can search for strings like system and eval, since these are common sinks for command injection vulnerabilities. So let's look at an example. Let's actually jump into a vulnerable code base and search for some vulnerabilities there. And the repository that we're going to be looking at today is called Tarpid Java, and here's the link here. Feel free to download it and follow along. Tarpid Java is a Java application that's seeded with a lot of common vulnerabilities, such as the OWASP top 10, several business logic flaws, as well as data leaks. So let's get started. So we have Tarpid Java open right here in Sublime Text, and let's start searching for some vulnerabilities. Let's first look for a hard-coded credential, for instance. So remember I talked about a lot of hard-coded credentials. They can actually be identified by searching for common keywords like key or password or string or API key, right? This is because a lot of the times when developers hard code their credentials in the code base, they actually name the variable or global name after these strings, right? So a lot of the times you can simply do a global search on the entire code base and see if you see any results. And you can see here that just right away we find a pair of AWS access keys right here, because their global names are named after the keyword key. And so another thing that we can be looking for via like a keyword search this way is that we can search for dangerous functions and see if there's anything suspicious there, or if there are any vulnerabilities happening there, right? So I talked about how the use of the function eval is a common signature for command injection vulnerabilities, right? So let's look for the keyword eval. So we can see here that in the file called servlettarget.java, and here is the use of the function eval. Let's go to that line in code right here. And so a signature of command injection vulnerabilities is the use of eval, which this function takes in input and actually executes it as code, right? So a common signature of command injection vulnerabilities would be user input being passed into this eval functionality. And you can see here that this is exactly what's happening here in the code base, is that the user provided parameter called module is passed into eval without any sanitization or any sort of safety measure. So this is actually a command injection vulnerability right here. So let's go back to the slides here. Yeah, so using this method, you can very quickly find a lot of different issues, security issues in your code. But what if you have more time, right? This kind of string search will not show you all the vulnerabilities that is happening in your code base. And it's actually quite insufficient if you want to find more subtle security vulnerabilities that are happening in your source code. So what if you have more time, right? What if you want to do a more comprehensive manual code review? So remember, I talked about getting familiar with the functionality and the components of the application, right? So after searching for obvious issues like hard-coded secrets or the use of dangerous functions in code by keyword search, start by analyzing in detail the different parts of the application that poses the highest risk to the users and to the application's business. So these are usually places where the client or the user gets to interact with the server, because these are the places where malicious input can enter the application. So first, you can examine the client-side code for security issues. Your client-side code is always something that you should pay attention to first, because that's where the users interact with the application first, right? So after analyzing client-side code, you can focus on code that deals with user input on the server side. And so anytime the application takes in user input, like HTTP request parameters, HTTP headers, or HTTP request path, these functionalities provide the entry points for attackers to exploit the application's vulnerabilities, right? So you could dive into these functionalities in detail and then trace the data flow of user input from these functions to other functions and see if they can reach dangerous sync functions. So tracing the data flow like this could really help you find more subtle but common vulnerabilities like stored cross-site scripting, SQL injections, XSEs, and so on. And then you should also review code that performs critical functionalities in the application. So this includes code that deals with authorization, authentication, or functionalities that deals with sensitive data or any other logic that that's critical to the business functions like payment, right? So dive into these functionalities and look at the protection mechanisms implemented on there and think about how you can bypass them, right? So this is when it will be really helpful if you think outside of the box and really think like an attacker. How would you attack your own code, and could any of the protection mechanism implemented on your code base be bypassed in any way? And at the same time, this is also a good time to look at the code and check how business and user data is being transported, and is any sensitive information being transported and stored safely. So let's look at another example, right? I understand that this is all quite vague, and the best way to really showcase how you actually do this is by looking at some code. So let's jump back to our code base here. So I talked about diving into the sensitive functionality in code, right? And the sensitive functionality that we're going to be talking about today is in this file called orderstatus.java. So what this functionality is actually doing is that first it's taking a request parameter from the user called the order ID here, and then it's passing it into a SQL statement in order to retrieve the order details associated with that order ID. And then finally, it is returning the order details to the user. So it's called the orderstatus.java, right? This enables users to check their order status by submitting a request to the server. So let's just take a quick 3 to 5 seconds to think about what could go wrong in a functionality like this one. So first of all, because this functionality is using user input and inserting it into a SQL statement, we could suspect that it might be vulnerable to SQL injection, right? And so this is exactly what happens here. You can see here that the user ID is passed into a SQL statement without any sort of sanitization or validation. So this functionality is actually vulnerable to SQL injection right here. And a second thing that we should think about is that since this functionality is dealing with sensitive user data, like the order status actually contains the user's credit card number, as well as their street addresses and their phone numbers, we could try to see if there are any sensitive info leaks going on. So here you can see that the order status, including the user's shipping address, credit card number, and email address, is stored into this order right here. And then eventually, underneath that declaration here, we can see that it's actually, this entire object is actually getting written into logs. And this is really bad because this means that whoever has access to the log files would have access to these user info right here as well. So this is really bad because this is a sensitive info leak into logs, and the very obvious vulnerability right here. So tracing the application's code from user input and from these sensitive data points to trying to trace these functionalities to sensitive sinks would actually help you identify a lot of different vulnerabilities that are hiding in your code. But as you can see, the process of manually identifying vulnerability in source code can be quite tedious and quite time consuming, right? And it's really not possible to review every single line of code that you write. And if you don't look at every single line of code, you can very easily miss something in the source code or miss some critical vulnerability that are hiding in your source code, right? So that's why first you need to really prioritize your analysis by really identifying what are the most important functionalities that exist in this application and what are the riskiest functionalities that exist in the application, and focus your analysis on those functionalities. And the second thing you can do is using automated tools, right? You can use things like SAS tools or static analysis tools to speed up the progress, right? Good static analysis tools will help you identify the vulnerable patterns that we talked about in this session so that you can focus on analyzing the results of the tools and really analyzing the impact of or the exploitability of the vulnerability instead of manually finding the vulnerable patterns yourself. So you can use SAS tools to speed up progress instead of tracing code yourself. And automation can help you with other components of the source code review as well. Like one of the other things that we do in source code review is that we look at all the application's dependencies and see if there are any publicly disclosed vulnerabilities that exist in those dependencies, right? And software composition analysis tools actually automates that process. It will keep track of your application's dependencies and see if any of them are outdated. You can also utilize tools like secret scanners to help you identify hard-coded secrets that we talked about in your code, right? So use these tools wisely can really cut down on the time that's taking you to conduct the manual analysis. But the issue is that these code scanning tools are never 100% accurate, right? So the best way to secure your software is really to use these tools first to identify as many as possible the suspected vulnerabilities in your code. And then you can conduct a manual code review to look at the areas of code that are deemed suspicious by your tools, and then validate those results via manual code analysis. And this way you can ensure that as few bugs as possible make it to production. So congratulations, you made it. That's the basic framework that you can use to conduct your very first security code analysis. But I would like to say that the stuff that I talked about in this talk is really just an intro. It's very basic, and it will definitely it's a good framework to get started finding the most common vulnerabilities and the most severe vulnerabilities in your code, but it's definitely not all that you can do in order to secure your applications. So if you're interested in learning more about the topic, I welcome you to check out the OWASP code review guide. It is a very extensive document on the topic, and you can learn a lot more like vulnerable patterns. How do you actually find different vulnerabilities in code that way? So check out the document, and thank you very much.